Okay, welcome back. Moving on in Module 1, still Topic 1, Lesson 5. Moving on to Activity 3, which is on page 52. Moving from the model to a procedure. You have drawn models to answer how many groups of a certain size are in a number. In this activity, you will analyze a few models that you drew to develop an efficient way to perform division of fractions without a model. So it says revisit the strategy to draw a model for 4 divided by 1/3, which they're telling us equals 12, and 4 divided by 2/3, which equals 6. So to create the model, 4 divided by 1/3, you partitioned 4 holes, so right here, 4 holes, to create 12 1/3 parts. So if this is 1, we cut it into thirds. Here's 2, and that's cut into thirds, and so on. And then there would be 12 separate parts, because 1, 2, 3 for that first one, 1, 2, 3 for the second one, so we're up to 6, 7, 8, 9, 10, 11, 12. It says, notice there's one step to this process. The denominator of the divisor, which is here, is 3. Partition each hole into 1/3 parts. This is the same as 4 times 3. Right? So if we have 4 holes and we're breaking it into parts of 3, into thirds, there will be 12 of those thirds in there. So to create the model 4 divided by 2/3, we still partition it into thirds, but then we consider it in groups of every 2/3. So this is a group of 2/3, and then here's another group. Here's a group of 2/3, another group, 2/3, and another group. So notice there are 2 steps to this. The denominator of the divisor is 3. So you partition each hole into thirds, which is the same as up here, 4 times 3. So we knew there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts. But then it says the numerator of the divisor is 2. So group 2 of the 1/3 parts together to create 2/3 parts. This is the same as doing 12 divided by 2. So we had 12 whole parts, and then we divided it into groups of 2. The combination of steps is the same as 4 times 3. So we had 4 divided by 2/3. So it's saying it's the same as doing 4 times 3. So we did 4 times the denominator, 4 times 3. And then we divided that by 2. It says you can rewrite a fraction as division or division as a fraction. So A divided by B is the same as written going across A divided by B. So let's say like for example, let's say we had just other numbers. Let's say 10 divided by 2. It could be the same as 10 divided by 2. That's all they're saying there, so that you can rewrite it either way. It then applies it to this problem by saying, so you can rewrite the final number sentence, this one, 4 times 3 divided by 2, which tells us there's 6 of those parts, so equals 6, as 4 times, instead of 3 divided by 2 like this, times 3 divided by 2. So 4 times 3 divided by 2. So notice we started here 4 divided by 2/3, and now it looks like 4 times 3/2. So we use the inverse of 2/3 or its reciprocal, which means we flip it 3 over 2. All right, moving on here to page 53. So it says compare the resulting equivalent number sentences from the worked examples. 4 divided by 1/3 equals 12, and 4 times 3 equals 12. And then 4 divided by 2/3 equals 6, and 4 times 3/2 equals 6. It says, what do you notice? So I notice when I change division to multiplication, I rewrite the divisor by switching the numerator and denominator. It says you just developed a rule you can use to rewrite any division sentence as multiplication. You can rewrite any division sentence as multiplication by taking the reciprocal of the divisor. So here it tells us A divided by B divided by C divided by D. So as a fraction, let's say we just say it as let's say, I'll use this one, but we'll do 4 over 1, because that's still the number 4, divided by 1/3. They're saying it's the same as saying 4 over 1 times 3 over 1. A reciprocal or multiplicative inverse is one of a pair of numbers whose product is 1. The multiplicative inverse of the number A over B is the number B over A, where they can't be 0, is all that says. So if A over B, let's say, is 2 over 3, then the inverse or the multiplicative inverse is 3 over 2. That's all that's saying. It's called the reciprocal or multiplicative inverse. So if we did 4 times 3, we get 12. And notice that's what we had up here. 4 wholes divided into 1/3 segments gave us 12 of those segments. So 4 times 3 equals 12. 4 divided by 2/3 equals 6. 4 times 3/2 equals 6. So let's multiply that across once. 4 over 1 times 3 over 2. If we multiply straight across, we get 12 over 2. And 12/2 is the same as 6. Okay, number 2 says rewrite each division sentence as a multiplication sentence and then calculate the quotient. So how do we write a whole number as a fraction? Well, we put it over 1. So instead of saying 5 divided by 1/4, we're going to multiply by the reciprocal. So 5 times 4 equals 20. 1 times 1 equals 1. We can put it over the 1, or we don't have to. It can be just the 20. 1/8 divided by 2 over 1. So 1/8, doesn't matter if the fraction comes first like this, times 2 over 1 is the same as 1 over 2. When we're using, instead of division, when we multiply by the reciprocal, which is 1 over 2. Multiply straight across, we get 1/16. Letter C, 4/5 divided by 1/3. So we kind of have a little phrase that we can use here. We're going to call it keep, change, flip is kind of the non-mathematical way to say it. We really are going to instead multiply by the reciprocal. So we keep the first one the same, change division to multiplication, and then we flip it or use the reciprocal, the multiplicative inverse, which means take 1 over 3, and just flip positions with the numerator and denominator. Now we'll multiply straight across, and we get 12 over 5. That's a terrible 5. We'll pretend it's beautiful. So if we change that to an improper fraction, or a mixed number rather, from an improper fraction. We could get 2 wholes out. 5 times 2 is 10. There would be 2/5 left. Okay, 3/10 divided by 1/3. So we keep the first one the same, 3/10. Instead of dividing, we're going to multiply by the reciprocal, which is 3/1. I'll just multiply straight across. We get 9/10. All right, so Alexa, it says, explain why Alexa is incorrect and provide the correct reciprocal. Alexa says the reciprocal of 3 8/5 is 3 5/8. So when Alexa did this, she only looked at the fraction part. And you can't do that. You cannot consider just the fractional part. The 3 is part of it as well. So you can't just consider the fractional part. So first you would need to change the mixed number into an improper fraction. So let's do that. So 3 8/5. So how many fifths are in 3 wholes? So if we're looking at fifths, 3 wholes would be, 1 whole would be 5/5. Another whole would be another 5/5. And 3 wholes, another 5/5. So there's 5, 10, 15 fifths, but then we already have 8/5. So 15 plus 8 equals 23/5. So there is a little kind of shortcut method to think about this. We can do 5 times 3, which gives us the 15, which is what we just figured out here. And then you add on the 8. So 5 times 3 is 15 plus 8 is 23. So 23/5. The reciprocal of that then is 5/23. Let's see what we have on the next page here. Okay, let's continue on. If you have 5 2/3 pounds of trail mix, how many bags can you make so that each bag contains 1 5/6 pounds? So we're taking 5 2/3 pounds of trail mix and we're dividing it into bags that have 1 5/6 pounds in each bag. Okay, so let's maybe first get these into improper fractions so that we can work with these. So 5 2/3. 3 times 5 is 15. So there's 15 thirds. If I'm talking about thirds and a whole number 5, there's 15 of them. So 3 times 5 is 15 plus 2 is 17 thirds divided by 1 5/6. Well, 1 whole in 6 is 6/6. 6 times 1 is 6 plus 5 is 11/6. So see, this would be hard to like draw a diagram. I wouldn't want to draw a diagram of this trying to do, 5 2/3 wholes and dividing it into groups of 1 5/6. So having this kind of algorithm and this method to do it makes it a lot easier. So we keep the first one the same, and then we change the division to a multiplication, and we multiply by the reciprocal. Okay, so we could multiply straight across, or do you see a way that we could simplify this before we do multiply? And let me just kind of show you off to the side here. So 17 thirds times 6/11. We could make this one great big fraction and put a times sign here. And then because multiplication has the commutative property, we could keep this here, and we could move the 3 and the 11. So 3 times 11 is the same as 11 times 3. And then right here I see 6/3. And 6 divided by 3 is 2. So when we look at it this way, if we're looking at this diagonal, 3 divided by 3 gives us 1, and 6 divided by 3 is 2. So there we have the same thing that we just had here. Okay, because we could change that to 17 over 11 times 2 over 1. So 17 times 2 is 34. 1 times 11 is 11. Now, if we didn't change that, we would have, I just kind of do this over here. We had 17 thirds divided by 11/6. Let's say we didn't simplify it. We did the keep it the same, change it to multiplication, use the reciprocal. And then if we multiply straight across, 17 times 6 is 102, and 3 times 11 is 33. So then from here, we could reduce it. We could divide them both by 3. I know that's divisible by 3 because 1 plus 0 plus 2 is 3. So the whole thing's divisible by 3, and I know this is 2. 33 divided by 3 is 11. That one is easy to do. And if I just show you this up here, 102 divided by 3. 3 groups of 3 out of 10, we get 9. 10 minus 9 is 1. Bring down the 2. How many groups of 3 out of 12? That would be 4. Okay, so we get 34, which, as you can see, was the same thing as here. Okay, a cook in a restaurant made 47.5 cups of mashed potatoes. If there are 1 1/4 cups of mashed potatoes in a serving, how many servings did he make? I can't imagine drawing out a group that is 47.5 cups long and taking 1 1/4 cups out of it. So we had 47.5, and we're dividing it into 1 1/4 cup segments or portions. So let's first make these improper fractions. 2 times 47 is 94, plus 1 is 95. So we have 95 halves. Change the division to multiplication. 1 1/4 is the same as 5/4. Well, let's do it like this first. Let's make that division, and we'll put 5/4 here. Now we'll do the keep it, change it, flip it. Okay, so 95 times 4, if we just multiplied straight across, 4 times 5 is 20, carry a 2. 36, 2 is 38. 2 times 5 is 10. So 380 divided by 10 is 38 servings. So there would be 38 1 1/4 cup servings out of 47.5 cups of mashed potatoes. So I'm glad we don't have to draw a picture of that. Okay, and then continuing on here with number 6. The hiking trail through Glacier Gorge and Rocky Mountain National Park is 9 3/5 miles round trip. If you hike 1 3/5 miles an hour, how many hours will the round trip take? So we're taking 9 3/5 miles, and we're breaking it down into 1 3/5 mile segments. So divided by 1 3/5. So how many hours will it take? you do 1 3/5 miles every hour, and that's how many miles you're doing, how long does it take? So we need to make these improper fractions. We could say 9 3/5, but we can't say times the reciprocal here without first changing it to an improper fraction. So we'll do the whole thing. So 5 times 9 is 45, and 45 plus 3 is 48. We have 48 fifths times, now let's still keep it divided by. 5 times 1 is 5, plus 3 is 8, divided by 8 fifths. Now we can do 48 fifths times 5 over 8. Now if you look right here on this diagonal, I see 5 over 5, because remember, this could be one great big fraction. And we could really flip the order of these. 5 times 8 is the same as 8 times 5, and 5 over 5 is 1. So if we looked at it this way, we kind of write it like this. So then we have 48 times 1, which gives us 48, and 1 times 8, which is 8, which we see here. 48 divided by 8 is 6. So it will take 6 hours total to go the 9 3/5 miles when you are hiking at a rate of 1 3/5 miles per hour. Okay, we'll see you on the next video.